Hey again, everybody. Here today to talk a little bit about chemical and physical changes and properties. And so we're going to do this with a little bit of a demonstration. There might be a lot of pausing in the video today, asking you guys to kind of think about all of the different properties that exist. And so in order to do that and still keep the video short, if I ask you to pause the video as you're watching, just give it a quick pause and try to think of some ideas before we go ahead and get started. Okay, so if you're following along on my guided notes sheet, there is a couple of questions right at the very top that I'd like to go over before we go ahead and get started into the lesson. If you're not following along, the questions are listed right here on the screen in front of you. So again, these are Regents-based questions, and these questions are going to be popping up here and there. Again, I'm not really entirely sure. As of right now, the Regents is still on, but we don't know what will happen with the remainder of the year. So I want to make sure that you are adequately prepared if the Regents does come your way. So taking a look at question number 1, it says, at STP, this term right here means standard temperature and pressure. Okay, so standard temperature and pressure, and we use that often to talk about just kind of basically saying that that's the baseline, that's the room temperature, that's our standard. Okay, so for right now, it doesn't really matter. In a couple of units, that will mean something a little bit more important. But at standard temperature and pressure, which 2-gram sample of matter will uniformly fill a 340 milliliter container? So I want to know, uniformly, again, means that it's going to basically distribute itself equally. So uniform means equally. So which one will distribute itself equally, okay, in a 340 milliliter closed is very important, container. So notice that we have all different things here. We have letter A is mercury, letter B is aluminum sulfate, a compound, letter C is potassium chloride, a compound, and letter D is fluorine. Now, that's not actually what's going to help us answer this question. What's going to help us with this question is the phase of matter. So which phase spreads out evenly to distribute itself amongst the container? And that is going to be the gaseous phase, and therefore the correct answer should be letter D. All right, question 2 asks, which substance can be broken down by chemical means? So which substance can be broken down by chemical means? Okay, so we have to think back to the video from yesterday and ask ourselves, okay, which substances can be separated physically and which ones can be separated chemically and which ones can't be separated at all. So remember, mixtures can be separated physically or chemically, okay? Compounds can be separated chemically, and elements cannot be separated at all. So taking a look at this, we'll notice that we have 4 different options that start with the letter C, okay? So we have copper, Cu, calcium, Ca, cesium, Ce, or carbon monoxide. So we're looking for the can be broken down. That means we're looking for a compound, okay? And so the best option here, the only option, I guess, is letter A. Now, what indicates that's a compound? What indicates it's a compound is the fact that it has those 2 uppercase letters, while the other ones have 2 letters, but they are uppercase, lowercase. All right, so now that we've got those questions out of the way, let's go ahead and jump right into today's quick lesson about chemical and physical change. So here's one of those points where I'd like you to be able to pause if you can or if you want to try to do some of these observations. So I'm going to hold up an object. I'm going to hold up a piece of paper. And what I'd like you to do is I'd like you to go ahead and record any observations you can think of with this piece of paper. So here we go. Pause your video if you'd like. Here we have a piece of paper. It's a standard piece of computer paper. So if you were going to go to your printer, you could grab this right out. So what are some properties that we can think of for this piece of paper? So here are just a couple of the properties that my students from last year came up with. Feel free to add them to your list. So for the paper, the properties that they came up with were that it was solid, okay, it is flammable, okay, it is a rectangle, it is white, it is thin, it is lightweight. Okay. They also said that it was flexible. And if you have other ones to add here, that's amazing. I wish I could ask for your input right now, but feel free to let me know in class, okay? So now the question is, are these properties that we just got here chemical or physical properties? So we need to go ahead then and define what a chemical versus physical property is, okay? So the chemical properties, or I'm sorry, let's start with physical properties. So a physical property, okay, a physical property is going to be a property in which it can be observed without changing the chemical composition, okay? So a property that is observable without changing the chemical composition. Okay, so what do I mean by that? Well, that means that if I were to look at this piece of paper and I were to say, this piece of paper is white in color. By saying that, does that change the chemical composition of this? Okay, can I test or observe that this is a piece of white paper without changing the chemical composition? Okay, and yes, we can, right? I can make that observation just by seeing it. I don't have to do anything to this piece of paper. Okay, a couple of other really good physical properties that we did not list here, but I would say are really good examples to think about are density of an object, right? I can measure the density of an object without changing the chemical composition, okay? And the phase of matter. Again, the fact that this is a solid piece of paper. So let's go back to our properties that we have listed, and let's go ahead and label them as chemical or physical, or at least physical for this part. So the fact that it's solid, again, that's a physical property. Flammable, that I don't think is physical, and we'll talk about that in just a moment. The fact that it's a rectangle it's physical. It's white is physical. It's thin is physical. Lightweight is physical, and it's flexible is physical. All right, so let's go ahead then and take a look at the definition for chemical property, okay? So a chemical property, okay, a chemical property by definition is going to be a feature, okay, that cannot be observed without changing the chemical composition. Okay, so without changing that chemical composition. So again, if we go back to our list, there's a reason I left flammable off of the physical properties, and that's because in order to observe that it's flammable, I would have to actually undergo that process of lighting it on fire and seeing if it's flammable. And in doing that, I would change the chemical properties of this piece of paper. So flammable is a chemical property. Okay, so now a couple of the most common ones of these, I'll make note of them for you here. Again, that's going to be flammability, okay, or the ability to rust. Can it rust or can it not? Okay, so how can I change this piece of paper? What are some of the ways that I can change this? So I'm going to go ahead and jot them down as I do it, and you can just, or if you want to jot them down as I do it, that'd be great. So first one, I'm going to fold the piece of paper, okay? I'm going to rip the piece of paper, okay? I'm going to ball up the piece of paper, okay? I am going to color the piece of paper. So I'm going to go ahead and use my Sharpie here and throw some color right onto that, okay? I could eat the piece of paper. I'm not going to do it actually, but I could, okay? And so eat, and color. And the last one that I'm going to do that is everybody's favorite, okay? Let me get my safety protection on, okay? Is I am going to burn it, okay? Please do not try that at home, okay? And so let's add that to our list here, things that we did, we burned it. So now let's talk a little bit about chemical and physical change, okay? So chemical change, okay, chemical change, okay, is going to be an alteration which changes the chemical composition. Okay, so an alteration which changes chemical composition. So folding it, it doesn't change the chemical composition. Ripping it doesn't change it. Balling it doesn't change the chemical composition. Eating it, it does change the chemical composition, right? If I were to digest that, that would. So that is a chemical process. Coloring it, again, doesn't change the chemical composition, but burning it does change the chemical composition, right? So if I were to look at this piece of paper now, we have a very obvious color change, and that's going to be an indication of that chemical change. Okay, what about physical change? What about physical change? So let's see. So a physical change, okay, a physical change is an alteration. Sorry for the handwriting today. So an alteration that does not change the chemical composition. Does not change chemical composition, okay? So which one of these are considered physical? Well, folding it doesn't change it. Ripping it doesn't change it. Balling it doesn't change it. Eating it, the physical process of chewing doesn't change it. Again, the digestion does, okay? And then let's see, burning it was chemical, but coloring it is physical, okay? So one last thing I want to go ahead and go over before we move on, okay? If I didn't just lose my notes, and I think I did, oh no. Okay, let's see if I can get that reopened for you. Okay, sorry about that, everybody. Technical difficulties, I guess. Okay, so my notebook. Okay, perfect. Here we go. So the last thing I really wanted to quickly go through was, again, reusing those particle diagrams we've been talking about in class and going through and showing you what that change would look like. So for example, let's start with a physical change, okay? So here I have my particle diagrams, and we're going to see a physical change, okay? So what's an example of a physical change? Well, how about going from a solid to a gas, okay? So we have my solid in my particle diagram here, okay? And undergoing that change of solid to gas goes like this. Now, how do I know that this is physical? I know it's physical because the chemical composition didn't change, right? So there's no change in composition, okay? It's still going to be, right, that these atoms are the same as the atoms on the other side. The atoms on the left-hand side are the same as the atoms on the right. And oh no, I am very close to running out of my 15-minute time limit, so let's go ahead and really quickly look at this. We're going to look at a chemical change. Okay, so let's say I had diatomic molecules over here. Okay, and more, let's see. I have two different types of diatomic molecules. Okay, and on the other side, we end up with a new molecule, right? So you can see from this that from here to here, the chemical composition changes. All right, everybody, have a fantastic day. I'll see you tomorrow.